One Network. Turn up your volume.
All right, and we are here live here in the studio of Action One Media. You're listening to or watching SG2 on Space, episode number 54. Slight delay in getting here because at this time of the year, people try to kill you. All right, personal experience here. So, in any case, just saying, all right, so we're back from break. Last week was Thanksgiving, so there obviously wasn't a show. So I figured today, oh, by the way, facebook.com/The Shen Show. Follow me there. Support me on patreon.com, patreon.com/SG2 on space. That would be wonderful. So please do that. In any case, so that is patreon.com/SG2 on space. All right. With that said, we can, Leonard, by the way, he's going to join us again. He's been on the show a few times, and typically I just ask him questions and we have a talk. So, anyways, so today with this, I figured just talk about random things. Why not? If you guys have a question, you know the number to call is 713-489-9250. 713-489-9250. So, or you can put it on the YouTube or Facebook while the show is going, right? So it's up to you what you want to do. All right. So first of all, I actually would like to talk about the moon in a little bit, but let's talk about some other stuff. All right. First of all, thank you SpaceX for successfully launching uncrewed Dragon spacecraft for NASA today. Routine as always, but still, spaceflight is dangerous, I would say. So it's good. This is a cargo mission, of course. No human beings. So departed, sending fresh supplies to the International Space Station, right? Which is all good. So everything's cool there. Some other interesting things. NASA's Parker Solar Probe is pretty much unveiling the sun's secrets, let's just say. So the first science results are in from NASA's Parker Solar Probe, which is the closest human-made object ever to the sun. So the initial PSP returns, which are reported in 4 papers published online December 4th in the journal Nature, basically has a lot of interesting science in there. So this, by the way, was not a cheap mission. It was $1.5 billion, okay? So, and it was launched last August, so August 2018. So the 2 long-standing puzzles the scientists have been, trying to puzzle out forever, but we just don't have data, is 1, how the stream of particles flowing continuously from the sun, known as solar wind, is accelerated to its tremendous velocities. And number 2, I think I mentioned this before, why the sun's outer atmosphere, or corona, is so much hotter than the surface. So the corona temperature can reach up to 2 million degrees Fahrenheit. and the solar surface is at 11,000 degrees Fahrenheit, right? And the Parker Solar Probe, it is basically barreling, like flying into the corona itself, and so that's what's going to happen. Every 5 months, it's going to barrel through the sun's atmosphere, quote unquote atmosphere, the corona, right? And it's also the fastest object that's ever been created by humans. The PSP, the Parker Solar Probe, is. Okay. Another interesting thing, there's a something weird about the craters of the asteroid Ryugu. So the asteroid Ryugu, a Japanese name, not exactly sure what it means, but it was visited by Hayabusa 2, the second Japanese mission to go to an asteroid, right? Okay, so Hayabusa 2 has already done studies a while back, but it took a lot of data, so Japanese scientists and other scientists took a while to notice things in the spacecraft's photos. So what did they notice? The team, this particular team, the Hayabusa team, used 340 different images of the space rock's surface and identified 77 craters scattered over Ryugu, right? But these craters, aren't as distributed evenly across the surface as as expected. So there are a lot more craters near the equator than the poles, and there are a lot more on the eastern side of Ryugu than the western. So, and why exactly is that? So, does it mean that the solar system has been just targeting this not very remarkable space rock? So, the researchers say not exactly. It's most of the equatorial edge is relatively old, but the westernmost part is younger. So that's why the craters aren't evenly, distributed. So the rest of the ridge have more time to pick up these impact craters. Okay, impact scars. And of course, you can look up more information. All right. So another thing I found interesting was that we say that where there's life. Oh, well, let's take a break. But let me just add one thing to this. Where there is where there is water, typically you find life, right? However, we have discovered one place on Earth that don't have life, even though it has water. And May 2019 article in Nature, read this one if you want. Ultra small microorganisms in the poly-extreme conditions of the Dalo volcano, North Afar, Ethiopia. So apparently Dallol, D-A-L-L-O-L, a geothermal field in Ethiopia, hot, acidic, hypersaline ponds. And there's no life there. So, okay, that may mean something. That first case possibly where there's water, but no life. All right. In any case, we got to take a break. When we come back, let's dive into some stuff about our moon and possibly other topics. So we'll be back.
Some of the other things you got going on.
Absolutely. So thank you for having me. I feel like I'm in the presence of like celebrities.
It's just the shades, man.
So I think like 2000.
the 7 trumpets sound, we gon' start the revolution. When we turn up, we shut it down. We are skywalkers. The spheres of my Kabbalah, illuminated properly in sight, shows the man in universe and the creator's gift of life. When the earth collides.
All right, we are back. You're listening to SG2 on Space, episode number 54. This is at the lovely Action One Media Group studio. And if you're listening live, today is December 5th, 2019. So here we have on Leonard. Oh, watch at facebook.com/The Shen Show. Or go on YouTube, SG2 on Space. All right, so we got Leonard Kramer on. Leonard is. Hey, Leonard.
Hey.
You know, I keep introducing you. How would you introduce yourself?
Leonard.
All right, wonderful. Okay. Leonard works at Boeing, and he's an aerospace engineer, and he also paints and plays with swords and does other cool stuff. So, with that said, I brought on Leonard a few times in the past, and, you know, we might keep doing this. So, I wanted to talk about the moon. And Leonard, I know you know a lot about astronomy and so forth. So one thing I was curious about is, so, you know, everybody sees the moon, right? If you live on Earth, that is. Is there something, actually, you know what? Let's start from the formation. Do you know, what are the popular theories of how our moon formed?
Well, right now, I think that the evidence is that it was some impact event when the Earth was forming. It was two planets basically coming in a impact event that tore off a piece of the primordial Earth. And I think we know that because of isotope and crustal constituents. There's common material that are present on the moon and on the Earth. And so I think the evidence is that it was very early in the formation of the solar system, and it's kind of a failed planetary accretion event. It's really quite unique. I guess most people know that there's 3 planets that are close to the sun: Mercury, Venus, and Earth. 4 planets: Mercury, Venus, Earth, and Mars. Those are the terrestrial planets. And then the other planets are gas giants, unless you want to count Pluto, which is really a Kuiper belt object. But anyway, the Earth is unique. The Earth-Moon is actually a planetary system, a little dual planetary system, which makes it unique in the solar system.
What do you mean by dual planetary system?
Well, of those 4 terrestrial planets, the Earth and the Moon are of the same order and size. So really, if you Mercury has no moon, Venus has no moon. Mars has 2 tiny little moons that are almost like satellites, Phobos and Deimos. So the Earth has a large moon that's of the same order and size as a planet.
Oh, okay.
So that you get what I'm saying?
No, I am asking this question for the sake of our audience, not necessarily for me. So, but so yeah, understandably, our moon is comparably similar to Earth, basically the planet that it revolves around, versus a lot of other worlds where the moon is so much smaller, like, for instance, the Phobos and Deimos, as you mentioned, of Mars. So the and that earlier thing about the formation of the moon, you said it was some object really early in near the beginning of our solar system, and essentially it collided with the Earth, and then a lot of material got ejected, and somehow it coalesced into into a ball.
Well, objects do coalesce because they're self-gravitating. You know, gravity pulls things together. So all of those things were molten originally. They were liquid, and they would pull together.
Yeah, no, that makes sense. Hey, if you don't mind, so we here on Earth we say, you know, there's the near side of the moon and the far side, and we can never see the far side from here. Why is that? Like, why is there one side of the moon?
That's very interesting. Well, the moon is rotating at almost exactly the same speed that it's orbiting. So it always has the same face facing the Earth. And that's not a coincidence. There's some physics, important physics, having to do with gravity gradient stabilizing of objects. So it means that the moon has internal gravitating inhomogeneity. It's more like something inside the moon is shaped like a dumbbell, you know, and it's not symmetric. And so one part of the Earth's gravity tends to pull on it harder than the other side, and then the part, the part of the moon that's further away gets attracted less, and so the moon orients so that dipole, that dumbbell shape is sort of pointed at the Earth more or less. Although it does wiggle back and forth. That's called libration.
Right.
So,
the thing where you said where essentially if has the same face towards the object is orbiting, that I believe is called tidal locking or gravitational locking. Does this happen with the other moons as well, or is this just unique to ours?
There's variations on this theme throughout the solar system. I don't know which other moons are tidally locked the way our moon is, but certainly Mercury has some resonances where every third or fourth orbit, something like that, is facing the same direction toward the sun. We talked a few.
We did talk about this actually.
About Venus, and so this is not something that's unknown throughout the solar system.
Yeah, and you're right. Mercury follows a 3-to-2 spin orbit resonance, but for something where it's like perfectly aligned, that's not as common. I think Pluto and its moon, Charon, Charon, Charon is another example. So, and typically it only happens when the distance between them are pretty small and the two objects are fairly comparable in size. So, like our Earth and our moon. So, nowadays, you know, there's a lot of interest in going to the moon. I suppose, you know, there's things that we want to find out over there or do something over there that we can't do on Earth. Do you know what are some of the things that we still don't understand about the moon that we want to find out, if you know?
Well, I'm not really an authority on the things that are not understood about the moon. I think there is some discussion about helium-3 or helium-4, but we don't know how to utilize that. It's a fusion fuel for the future.
Well,
people talk about that. That would have its origin in the crust of the lunar surface over eons accumulating solar wind.
Yeah, actually, why don't we talk about that a bit? About, say, let's talk about resources on the moon, right? So if we're ever going to live there, you know, we have to be self-sustainable. So and you mentioned helium-3. Let's talk about that for a bit. So what is this helium-3, and why do we care?
There is a fusion reaction, nuclear fusion reaction that utilizes helium, but we don't know how to do that yet, except in other words, the technology doesn't exist to exploit it. But there's a lot of talk about that. Certainly, water. There's lots of oxygen there in the rocks. Combined with rocks. I think hydrogen is limited. Any sources of hydrogen. However, it's thought that at the poles of the moon, which are in deep craters that are always in dark, there's a substantial amount of water that has accumulated there, and I think probes within the past 10 or 15 years have been able to verify that that's true. So the poles, especially the north pole of the moon, is a likely place to set down and settle and use the resources for particularly water. So water is a source of hydrogen. Hydrogen is a fuel that could be used. Of course, you need to put energy into it to crack the hydrogen from the water. The moon rotates so slowly that for 15 days it's in darkness. You're in, the nights are 15 days long, half a month long. So the pole is a likely place to set up solar arrays to see the sun continuously.
Right, because I've read about there being certain parts of the what do you call it, peaks of eternal light. Where hypothetically there's places on the moon that's pretty much always in sunlight, and I suppose those are all near the poles. That would make sense due to the angle from the sun. So, so you mentioned water, which could be used obviously for life. We need that, and I don't know if you mentioned it, but it could also be used for rocket fuel, propellant. And how about so can we use the lunar soil or something to build a structure for people to live in?
Well, it is kind of incumbent on us to go underground because the radiation environment over the long term on the moon is a hazard. So that's something that needs to be dealt with. In fact, that's actually the long-standing or the major issue with exploration of the solar system is the radiation environment. The astronauts that went to the moon in the late 60s and early 70s were only exposed for about 3 days, and no really serious events occurred. But that's something that's going to have to be dealt with one way or another in order for humans to exist in interplanetary medium for an extended length of time. So being under the surface seems likely. I have read that there are lava tubes believed to be areas where in ancient primordial time that lava flowed, and then there's caverns and that sort of thing. So those would be the sorts of things that you would want to be looking for if you wanted to explore the moon. The moon is also a kind of a technology test bed, a place to go to test your technology for extending out toward Mars and outward into the solar system.
Right? That makes a lot of sense. So now, it seems like in recent years there's been a lot more talk of going there, all around the world. Do you know, Leonard, why there seems to be a resurgence of interest when for 40 years we didn't really hear much about actually going there?
Yeah, it's kind of sad, really, that it's been so long. I was 11 years old in 1969. And I remember they asked, I was a space nerd then. I mean, I knew the Saturn V, I knew everything about the rockets and the astronauts, how it launched, how it landed, and all that. A little nerdy brat. And we never expected 50 years to go by where we did not return to the moon. So it's disappointing, and I think maybe the urge is just built up now. I have to say the shuttle was not helpful in that regard, but the space shuttle ended up costing so much money and not really delivering what we were promised technologically. I don't think that's anybody's fault exactly. It seemed like a good idea at the time. It's just that that's a lesson learned.
So are you?
And right now we are on track. I mean, we're Orion and the other entries into the space industry are on track now, especially the United States, because Orion is giving some capability that and what they call Artemis, it's now called Artemis program, is on track, and it's going to fly. It has solar cells, and capable of traveling to the moon or outside the Earth's environment. No, I don't think there are any other countries that are developing that capability right now. You hear a lot about other countries and Elon Musk and the European Space Agency, Japanese Space Agency, but those are all slated for low Earth orbit access to the space station. So anyway, things are looking up. That's how I feel about it.
Literally. Yeah, man. I was not alive back then, at least in this world, as I am right now. Who knows about reincarnation? I'm not going to go into it. But I wasn't Shen then, so I did not see humans on the moon. But I think reading historically, it is very surprising that like a few decades passed before, actual any missions are planned to land there. So Artemis program, really, Leonard, as you said, excellent. For people watching, to learn more, you can of course go to nasa.gov/specials/Artemis. And as a background to people listening, the Artemis program is the goal is for NASA to land the first woman and the next man on the moon by the year 2024. So,
hoorah!
And then establish, collaborate with commercial, in other words, private companies, and international partners, which means, say, JAXA or ESA or whatever other space agency, and establish sustainable exploration by 2028. So the plan here is go back to the moon by 2024, and then not just footprints on the ground and then not care about it, but actually take a sustainable approach and establish a permanent settlement there with commercial companies and other international partners. So this is definitely a different take than back in the 1960s and early 70s. So my hope is that that this will proceed as planned. So in any case,
I was going to say, Shen, this kind of thing, a lot of people poo-poo it and try to say, well, it's a waste of money and so forth. But
actually,
this is our spirit. This is not that expensive compared to other things.
Let me ask you this, Leonard. I was actually in conversation, in fact, multiple conversations with, really smart friends of mine who are not really into space. And then the argument is always like, there's no point going to the moon. It's just a waste of money. What are we doing? There's so many things going on Earth, and we're wasting a lot of time and effort. Like, there's no point in going there. We already went there. What would be your response to that?
I said, well, it's not so expensive. and we can do so many things that with the resources we have. We're richer than we've ever been. If I had to pick one point in 200,000 years of hominid evolution when to live, it would be right now. And it's incumbent on us to explore and understand the environment we live in. That's kind of I understand the angst and the issues. Those were things that were talked about 50 years ago too. So I would say it lifts our spirit. It inspires us. It makes us see the possibilities.
Mm-hmm.
It makes us work together. It also creates international international cooperation. In other words, if you could think, there's so much antagonism between Russia and America,
right?
But we still cooperate in space, right? And so there are Russian cosmonauts and Americans and from other countries on the International Space Station. So that's how I would answer. Maybe it's a little awkward, or maybe it's not. Doesn't sound
well. I actually want to ask
wonderful.
You a specific question here. You said people have the idea that it's super expensive, but you said it's really not. How much would it be?
Well, for every American, it's a few cents per year, right?
Okay.
The space program is less than $20 billion, and we have a $20 trillion economy. How many zeros more is that than 20 billion?
A lot.
Yeah. So it's basically a drop in the bucket. That's
six more zeros, I think. Yeah.
What?
Isn't it 6 more zeros?
It's 6 more zeros. So it's something like 1 million. Is that possible? Is it 1 millionth of the U.S. economy? So, and of the world economy.
Yeah,
so
because 20 million to 20 billion, you have to multiply it by 1,000, right? Yeah.
Yeah.
Wait, hold on a second.
So,
no, that's 100. Oh man, I'm embarrassing myself here. I should be able to do this kind of math. So.
Yeah. Well.
Oh my gosh. So when we go to the moon, Leonard, where should we go first? Should we go to the poles, like you said? Is that where the attention is?
Oh, I'm gonna leave that to the people who do it best. We talked about the poles,
right?
If you really, it needs to go at the poles because, just from what I know about it, you're going to be in 15 days in darkness.
Right.
So it seems like you want to find a place where you have sunlight so that you can produce electricity from solar, and that would be how I would go about that.
No,
I mean,
that makes a lot of sense.
If we can get over the fear of using nuclear reactors, I mean, we could use nuclear reactors just the way military submarines use reactors, and that's a regular kind of thing. But there's a lot of political fear and nuclear things into space.
Makes sense. So we're running a bit on time. Leonard, besides the moon, whatever, do you have something else cool about space that you want to briefly discuss or share?
Oh, well, I'm pretty interested in cosmology these days, and the origin of the
origin of the
universe.
universe.
But maybe that would be better for another day.
That'd probably be better for another day. Although, speaking of cosmology, have you heard of I think I just informed you, unless you already knew about this Hoag's object, HOG. Have you heard? Yeah, Hoag's.
Like ring galaxies that are shaped like rings.
Yeah, have you heard of that?
Yeah, of course. There's a few of them.
Yeah, they're really rare.
I think they're a mysterious thing. I'm not sure what that is.
So
I think it's a.
Well, like I was reading this earlier about this particular object called Hoag's object, HOG''S, and it's literally like a perfectly symmetrical ring. That's like the actual galaxy, which is crazy. Like, how does that happen? And they've disproved the fact that it's gravitational lensing. It's not. It's actually there. And they've also shown that it's not formed by some other galaxy, colliding with it. So it's just really weird. So
yeah, well, things do form rings. I mean, we have Saturn, and we have several other examples of faint rings throughout the solar system.
Right, but
Plus
this is a galaxy.
The whole solar system is a ring, right? So we do have that precedent. Now, a whole galaxy that's shaped like a ring.
That is weird. So
is very wild.
Yeah, and there's also something like within this particular galaxy, Hoag's object. There's like a galaxy inside of this ring galaxy, like that's further away. So that's really weird. So, but yeah,
I agree.
Any case, all right. Well, we need to talk about cosmology some other time since we started a bit late. Unfortunately, we gotta cut this. We gotta end this show. But so thank you, Leonard, for your time and your enthusiasm and your sense of humor. So, all right.
You're welcome. Likewise. And
okay.
Have a safe drive.
Yeah. So everybody else watching this, you've been listening to SG2 on Space and here in Action One Media Group. I'm going to do a shout out to Mary Beth, Miles Monroe, and Colonel Burton. Thanks for the comments, which I think Colonel Burton is Leonard, unless I'm mistaken. So I'm going to go with that. And of course, I'm
maybe his alter ego or something.
Wouldn't that be funny? Your alter ego is commenting on you talking. Got it. So, all right. With that, guys, follow me at facebook.com/The Shen Show. Donate if you wish at patreon.com, patreon.com/SG2 on Space. And with that, I wish we had time to talk about aliens, but that gotta wait. So, but I will put some stuff on my page, so feel free and we can talk about it online. All right. So, facebook.com/The Shen Show, okay? That's where alien stuff is going to go. All right. And other things. So, what's the catchphrase? Look up.
Keep looking up. You
well,
better do it.
Okay, nice try. Close. Look up because you never know what you will see. All right? So, good night, everybody.
Good night.
Put your money.
Man, you still here? Go on and subscribe.
Put your money where your community is. Get in the
Growing
action
up as a black kid in New
at
Jersey,
weareA1.com.
all I ever wanted to do was be a pro athlete. All of my role models were black athletes. And every time I would stare out the window and look at the sky and wonder what I'd be in the future, it always had to do with me catching some crazy football and scoring a touchdown. When it came to the point that I was told that I would not be able to play on an organized sports team for the rest of my life, it was something that I really didn't even know how to stomach in the moment. And I remember walking out of my cardiologist's office and just sitting in the hallway and breaking down for a few minutes just because it was something that I just couldn't plan for and couldn't account for. And I realized that in that moment, my entire life was going to be changed. And all of those dreams and hopes and aspirations that I had were going to go out of the window.
Peace, it's Brother Atum Ra, and you tuned in to Action One Network.